right, so now that we have created our sediments, we have transported the sediments, and now we have deposited the sediments, what then happens to them? So at this point, we still don't have a sedimentary rock. What we're going to need to do is take the sediments and somehow squish them together and turn them into a solid sedimentary rock. So here's some different ways of doing it. So the first one is going to be just plain old pressure. So taking the sediments and then squeezing them together until they stick together. So you don't need to cement them together with anything. You don't need to apply heat to them. All we're going to do is just squish them to the point at which they stick together. And a common example of this is clay. So the sediment normally has a lot of water in it. And so if you can squish it to the point that you're squeezing out all of that water, eventually it might stick together, and then you end up with the sedimentary rock clay. Okay, another more common thing though is that the sediment is going to be glued together. And so one of the most common types of glue is going to be calcium carbonate. And so that particular substance can glue the pebbles together and make that kind of sedimentary rock. So how are you going to know that it's been glued together with calcite? Well, do you remember that calcite's a mineral, and what happens when you put acid on calcite? It fizzes. So if this sedimentary rock is glued together with calcite, then if you put acid on it, it will start to fizz. Okay, another thing that can be used to glue it together is going to be silica, quartz. So silica can be dissolved in water, and then when water gets in between those cracks, then the silica is deposited in those cracks as quartz. So what do you think would happen if you put acid on a conglomerate that is composed of pebbles that have been glued together with quartz? Well, nothing, okay, because quartz doesn't react to acid. Another thing that could happen is it could be rust. So we said that one of the common things that comes from weathering is going to be rust. As a matter of fact, the three things that we said were the common results of weathering of rocks at the surface of the earth was clay and quartz and rust. And you notice that all three of those things are used to glue these pebbles together. So rust, iron oxides, can also glue the pebbles together. Okay, another kind of lithification is when crystals grow and then they interlock with each other. So this is going to be very common like with limestone. So if you've got calcium carbonate that is dissolved in the water and then it precipitates to the bottom of the ocean floor, then those crystals will interlock with each other, and then you get a type of limestone as a result of that. There are other kinds of crystals though. So if you recall, salt is something else that could be precipitated to the bottom, and so then you end up with rock salt. You end up with the mineral halite as a result of it. So we'll look at some other examples of evaporites, examples where crystals have interlocked and formed a sedimentary rock. Now that fourth example is going to be recrystallization, so that you have one kind of sedimentary rock that is composed of crystals, and then those crystals reorganize themselves into a different pattern. So that, for example, animals in the ocean make their shells using calcite. But then what can happen is that the calcite in the shells can reorganize themselves into a different kind of mineral, which is called aragonite. Now, aragonite is also made of calcium carbonate. But notice that calcium carbonate, when it's in the form of calcite, makes these shapes that make the angles like this. Whereas in aragonite, okay, so when you make the mineral aragonite, the atoms reorganize themselves and then they make crystals that make angles like this. So that's an example of a recrystallization. And so all of these are different methods that hold the sediments together to make sedimentary rocks. So what are the factors that are going to affect lithification? Well, one is going to be temperature. So the temperatures at which these sediments will be lithified is between 0 and 300 degrees Celsius. So if you go above 300 degrees Celsius, then what's going to happen is you enter the realm of metamorphism, which is going to be a future lesson. Okay, let's look at the pressures. So the pressures can be anywhere between 0, which means that these particular rocks are lithifying at the surface, to 2,000 atmospheres, so 2,000 times the pressure that we're feeling right now, and that would correspond to a depth of about 7 kilometers inside the Earth. So we don't want the pressures to be any higher than 2,000 atmospheres, because then, again, we would have metamorphism that would occur. Okay, it also depends on the type of sediment. So pebbles, when they're glued together, are going to make one kind of sediment, but leaves and organic material, when they're glued together, is going to make a different kind of sedimentary rock. And then it also depends on what are the cementing agents. Is it quartz, silica, that is cementing the stuff together? Is it calcite, or is it iron oxides? All right, in our next segment, we're going to talk about where do you find sedimentary rocks.